Hello guys and welcome back to the channel. So today we're going to be covering ratios and proportion, which has been something that has been widely requested, and I've finally got around to making it. So with ratios and proportions, these questions are kind of not necessarily too bad to do. They just follow similar principles, and there's a couple of things to understand. So the first thing is that ratios are fractions in disguise. Okay, so for example, if I tell you x to y is 3/4, you can say 3/4 equals x over y. Okay, so so it's basically like, you can almost imagine it's like numerator, and then this becomes the divide sign, and then denominator. Okay, so that's the first thing. So they're quite simply just fractions in disguise. The second thing that's important is when you're trying to work out these ratios and proportions is trying to use your mental maths to simplify ideas. So for example, if you got that the ratio between two things is 120 to 50, right, that's 12 to 5. Okay, so just little simplifications like that. But also just on a more kind of intrinsic level. So if I got something like 238 to 63, right, that's hard to simplify. But if you look at the answer options, and A and B both say 1 to 2, or 1 to, or even something like 12 to 48, you can see A and B both have to be wrong, because here the number on the left is greater. Here the ratio is going to be greater than 1. It's 238 over 263, which you said is the same as 238 divided by 63, right? Whereas this is equal to a half, which is going to be less than 1, and this is equal to 12 over 48, which is also going to be less than 1, okay? So you can immediately rule answers out. So one of the mistakes that I see people making is that they'll work out the ratio, they'll do the hard work, they'll work out the ratio, and they'll just plow all the way through. They'll just put in A into the calculator, put B into the calculator, put C into the calculator, and I think, well, you don't necessarily need to do that. Remember, the UCAT is very cynical. You have to treat it with the same cynicism that it treats you, okay? So this idea of guesstimation. So for example, if one of the answer options here was something like, I don't know, 7 to 2, that's perhaps a more doable version, right? That is perhaps more likely to be true, because that's about, that's 7 over 2, that's about roughly over 6 over 2, which is about 3, and this roughly looks to be around somewhat like 3. Okay, so choose relevant answers to go through. So 100% you can put them into the calculator to work out what the ratio would be. So that's what you probably would do with this question. So you do 238 divided by 63, and that would give you 3.77. Obviously, when you put 7 over 2 into the calculator, that'll give you 3.5. Okay, but you can see it's in the right region. Okay, but you can see how mental maths is going to be very, very helpful here. Okay. Cool. The other thing is, read the question carefully, okay? So make sure you're doing the ratio the right way. Ratios don't necessarily always have to be biggest one on the left or biggest one on the right. It's not like that. Just read what it is. If it says x to that, do it in that order. So ensure you're doing the correct ratio. And fundamentally, when it comes to ideas like ratios and proportions, it's important to understand some key concepts. So the first one is kind of like how maps work. So the way that maps work is, it works on ratios, as you know. But all the ratio means is, so for example, if it's 1 to 30,000, it means that 1 centimeter on the map, okay, represents 30,000 centimeters in real life, or whatever it is. But it doesn't matter what units it is, really. Normally it will be cm to cm. But if you think about it, it's just a ratio. So technically, 1 kilometer on the map would represent 30,000 kilometers. As long as the number is 30,000 times bigger, it's fine. So that's all that the map is. So for example, if something is 2 centimeters on the map, that means it's 60,000 centimeters in real life. 60,000 centimeters is equal to 600 meters, which is 0.6 kilometers. Okay, so then you'd work it out like that. But these are important kind of points to have a think about. And unless they specify otherwise, they might specify like 1 centimeter represents 3,000 meters, right? If they specify otherwise, obviously use their specifications, but normally this is how I would say maps work. The other thing I think that's also really important to understand is basically how we can work out proportions and divisions. And so we'll see that a little bit more in the next question that's coming up. But basically, so for example, let's say I have £200, and that's shared in a ratio of 3 to 2 to 3 between me, my best friend, and some other person. Let's call it X. So how much would each person get? So it's quite a simple question. So what you have to basically consider is that this 200 is being split into parts, and it's being split into all these parts. That's 3 plus 2 plus 3, which is 8. So it's being split into 8 parts. So you have to do 200 divided by 8 first of all to figure out how much one part is, basically. Okay, and so you figure out that one part is 25. And so you can see I get 3 parts, so I get 75. My best friend gets 2 parts, they get 50. And the other person also gets 3 parts, that's 75. So you can see it's not too difficult to do. It's just about making sure that you add up. So whenever you're fully dividing proportions, add up all of the totals, add up all of the parts, divide by the total number you have, and then split into constituent parts by multiplying back up. Okay, great. So let's go on into our first question then. Okay. So the recipe also required 2 parts sugar to every 7 parts salt. How much sugar will be required to bake 5 loaves? So when I read this question, these are some of the key ideas that I'm trying to look and understand for. So 5 loaves, so I'll see up here that it requires 10 loaves, right? And it gives us a value for salt and they're asking us for sugar. And they've told us sugar to salt is 2 to 7. And we want to work out the amount of sugar, we have the amount of salt. We know it's 112, but that's for 10 loaves, so we need half of that, which is 56. And so here, this is a slightly different question. We're just kind of scaling things up. So if you have 57, and that's split, and 56 falls into this ratio. So it's not like you have, so in the question before I said, remember, there was a total amount, and you divide that into 2 and 7. Okay, it's not like that. Here it's telling us, okay, there is 56 grams, so we can use that definitively. Okay, so we take that number, and so you see, okay, so how much do you have to scale up by? So 56 divided by 7 is 8, and so therefore you have to times this by 8 as well, so you're going to have 16 grams of sugar. So really not hard. Okay, so let's go on to the next question. So Rachel makes 9 loaves, 1 for each of 9 friends. 2 are allergic to olive oil, so she makes loaves without it. How much olive oil does she need? So that means that she makes basically you need olive oils for 7 people. Okay, so remember this is 10 loaves, so we only need 7 loaves worth. Okay, so you do 7 over 10 times the 426 grams of olive oil. So this is kind of like, so if you think about it, for 10 loaves you need 426, we only need 7. So what we're doing here is we're basically dividing the 426 by 10 and multiplying it by 7. So you divide by 10 to get how much you need for 1 loaf, and then multiply by 7. Then the fast way to do that is just to find 0.7 of the total amount. So 426 times 0.7 is 298.2 grams of olive oil. Okay, cool. Okay, great. So on to the next question then. Okay, so you can definitely see it looks a lot harder here. So for every 2 flights that depart from London to Moscow, 5 flights go from Washington to Moscow. Alongside this, half as many flights leave London to Moscow comparing those leaving Sydney to the same destination. Flights from London and Sydney to Moscow must connect through Amsterdam, and 15 flights leave from Washington to Moscow. How many okay, so take it bit by bit. So London to Moscow. So you can see we have to make ratios here. So London to Moscow, Washington to Moscow, and you've got Sydney to Moscow, I believe. Okay, so for every 2 flights that depart from London to Moscow, 5 flights go from Washington to Moscow. Alongside this, half as many flights leave London to Moscow compared to those leaving Sydney to the same destination. So Sydney must be 4, because if it's half as many leave London to Moscow, then Sydney must be 4. Flights from London and Sydney to Moscow must connect through Amsterdam. So this one and this one have to connect through Amsterdam. If 15 flights leave from Washington to Moscow, how many connecting flights depart from Amsterdam? So this question is easier than what it looks. Once again, let's figure out what the scaling up is here. So multiply by 3. So then therefore we'll multiply this by 3 and we'll get 12. And we'll multiply this by 3 and we'll get 6. So in total, these are the ones that depart from Amsterdam. You can see I didn't really look at the table at all, because here, if you have a quick glance up, it says the table shows the average direct flight time. Like, it's really not necessary. I had more than enough information in the question to be able to properly and fully answer this. So even though it's difficult, like I said, just take it bit by bit. Okay, cool. So let's go on to the next question. So what is the area of the cereal factory on map 1 in meters squared? Okay, so what's the area of the cereal factory? So remember what I said, the scale of the map is 1 to 30,000. Okay, so the area on the map is 5.2 centimeters times 4.2 centimeters. Okay, to make my life easier, I'm probably going to convert it into meters squared, because I'm gonna have to get them as meters squared eventually. Sorry, I'm going to convert it into meters because I'm going to come as meters squared eventually. So the point here is, remember what I said about the scale. The scale is not fixed for a unit. It's not like 1 centimeter has to be 30,000. It means like 1 to 1. It just means there's that ratio of 30,000. Normally it is 1 centimeter equals 30,000. So therefore, what I have to do here is, so this would tell me what the area of the map is. Okay, the area of the area of the area factor on map 1. But to figure out its actual area, I have to multiply each of these values by the 30,000. So that's like 1, and then times that by 0.042 times 30,000. Okay, so 0.052 times 30 times 0.042 times 30,000. This is going to give me... Oh, I must have typed something wrong there. So 0.052 times 30,000, which is 1560, and then 0.042 times 30,000, which is 1260. And then to finish it off, so it becomes 1,965,600 meters squared, which I guess probably is quite accurate for a serial factory as such. Okay, so yeah, so you can see, not too difficult. The other thing we could have done as a little slightly faster way is you could have just multiplied these two together. And once you did that, you could have just been like, oh, just did the times 30,000 right at the end. So you could have done 0.052 times 0.042 times 30,000 times 30,000. Because it's the same calculation as what's happened, the line below, basically. Okay, so what's the area of the serial factory on map 3 in acres? Okay, exact same way that we do it. So we want it in acres again. So once again, I think putting it into meters squared is going to be appropriate. So for area on map 3, so all it's going to be is 0.036 times 0.025. 36 times 0.025. But then remember, we have to multiply that by 30,000, and then again by the 30,000, times that by 30,000, times that by 30,000, which gives you 810,000 meters squared. 10,000 meters squared is 2.47 acres, so 10,000 meters squared is 2.47 acres. We have 810,000. We want to figure out what x is. So what you do is you do 810,000 divided by 10,000 to figure out how many times you have to multiply that by. So times by 81, times it by 81 there as well. Okay, so times that by 2.47, and so you get 200. So x equals 200.07 acres. So I know that this sounds like feels like it's taking us quite some time. That's because I'm explaining it. But as you get good at it, you can basically just like think to yourself, okay, so 810,000. Okay, it's like basically whenever you're lining it up with the ratio. So here we kind of lined it up together, right? So all you have to do is whichever number you get. So if you get the 810,000, divide by the constituent part of the ratio and multiply by the other one. That's all it is. So if I got given the acres here, I would divide by the acres and then multiply that with this. And that's all the ratios is. And so that's kind of like the faster way to do it. Like you don't have to think about it each time, if that makes sense. So if I was going to give you an example, so let's use another ratio. So for example, if the ratio was 3 to 4, and I got given that this was 7, you have to work out what x is. All I would do is divide by 4, and then times by 3, and you'll get your answer. Okay, so you can, like I said, so whenever you've got given a ratio, so divide by the constituent side, then multiply by the opposite side. That's like the fast way to think about it. So here, when I see the 810,000, I'll just divide by 10,000 times by 2.47. Okay, great. Okay, let's keep going. So the proportion of total applications submitted to residential applications accepted without appeal in 2005. So 2005, total applications submitted to resident applications accepted without appeal in 2005 was 5 to 2. So this is how many were accepted. This is how many planning applications were accepted. And I think they're asking us for how many non-residential. So basically, the idea here is you've got planning applications, and planning applications can be residential or non-residential. And they're telling us, they're saying that the proportion of total applications submitted, this number, is compared to the ratio of this one is 5:2, and they're asking us for how many this one is, therefore, basically. So what we have to do now is 1905 to, let's call this number x, is 5:2. So to figure out what x is, remember what I said. Take your number, divide it by the same side, multiply by the opposite side. So it's just going to be 1905 divided by 5 times that by 2 is x is 762. So we know 762 residential applications were accepted without appeal. And so how many were non-residential were accepted without appeal? So this is the appeal idea. Okay, so without appeal. So here we've got 1525 that were accepted in total without appeal, and we're told that 762 of them were residential. So the non-residential ones that were accepted without appeal is simply this minus that, which is 763. Okay, so how many non-residential applications were accepted without appeal? 763. So I know that the wording here can seem quite tricky, but honestly, if you just take it step by step, it's not going to be as bad as you think it is. Okay, on to the next question then in that case. So I apologize for not getting this question out a little bit earlier. I know it's been sitting in my question bank for quite some time now. But what is the ratio of the total number of truck drivers to the total number of loggers in the country? So all this is basically ratios in disguise as such. So it says number of fatalities on the job per 100,000, number of fatalities at work. So if you think about it, we're looking at truck drivers and we're looking at loggers. So I'll explain it slowly first of all. So it says there's 24 fatalities per 100,000. So per is kind of another indication of like, oh, this is a ratio question that's going to be coming up ahead. So there's 24 fatalities per, so this is for the truck drivers. 24 fatalities per 100,000. And it tells you in total there's 840 fatalities. So remember what I said, divide by that same side, multiply by the opposite side. So 840 divided by 24 gives me 35. And then when I times that by 100,000, I'm going to get 3.5 million. Okay? And so that's how many total truck drivers that I have. Because this is deaths, this is per 100,000. This is the workers that you have. So there's 24 deaths per 100,000 workers. We know there's 840 deaths in total. And so you just have to scale up that ratio. And the way that you do it is you divide by 24 times by 100,000. Okay? And then do the same thing for the loggers. All it becomes is it's just going to be, so there's number of fatalities on the job per 100 workers is 80 to 100,000. But it's just this answer is a little bit dodgy because there's only 56 deaths. And you think, how's that possible? How's there less deaths than the ratio? Well, that's because the ratio is per 100,000, remember. We follow the exact same logic. Divide by 80, multiply by 100,000 to work out what x is. So 56 divided by 80 times 100,000 gives us 70,000. Okay, so therefore, all you have to be doing here is what's the ratio of total number of truck drivers to total number of loggers? You take your two numbers, and remember what I said, just follow the order. So truck drivers to loggers, 3,500,000 to 70,000, and make life easy for yourselves. Simplify and cancel. Get rid of the 4 zeros there. So that's 350 to 7. You can divide that by 7 again. So it becomes 50 to 1. So the ratio of truck drivers to number of loggers is 50 to 1. And if you want to write that as just a pure number, remember, a ratio is a fraction in disguise. So it just becomes 50. Okay, so I hope that makes sense. So I know that, once again, these questions can seem tricky, but I promise you it's not as bad as what people may think they are. All it is just about following that formula, understanding, for example, how math questions work. Obviously, that's one instance of where ratios are used. I think other instances are like equations where they talk about cakes and different types of batter and ingredients you have to make and things like that. But like I said, none of these questions are necessarily intrinsically difficult. It's just about understanding them. And if you guys made it this far into the video, please do like and comment. And if you haven't done so already, please watch my QR walkthrough videos, especially the ones that talk about the most optimal way to actually answer questions, because part of reviewing and part of answering questions is about having the understanding and being able to be like, okay, you know what, this is, I've seen this style of question before. Oh, this is a ratio question, this is a proportion question. I just need to get to doing the maths. So you can see this is genuinely like, yes, it seems like I've done a lot of working here, but I would just put this into a calculator. 840 divided by 24 times 100,000, 3,500,000, write that down. 56 divided by 80 times by 100,000, 70,000. Okay, do a little bit of mental math and then solve and cancel down 50 over 1. Genuinely not that necessarily that bad. Okay, so thank you as always for watching, guys. Sorry this video took some time to come out, and I will see you guys in the next video. Okay, so thank you as always, and please do keep your comments coming in, and best of luck to anyone who's writing their exam, whether it be today,